So welcome back to Pharmaceutical Concepts. Our next question is resolution of spectrophotometer is. Okay, what do we understand by the term resolution? Here spectrophotometer means this is the device, okay, which is used, the instrument. Basically this is the instrument which is used for the analysis of the sample by spectroscopy, like UV, IR. There is UV spectrophotometer, IR spectrophotometer, and this term resolution, this we use with respect to spectroscopy also, and this term we use in case of chromatography also. And what is this resolution? Resolution is the ability, this particular resolution is the ability of this particular instrument to distinguish adjacent absorption bands. Means what? Means using these spectrophotometers, for example IR instrument, UV spectrophotometer, or the chromatography. When we use these instruments for the analysis of sample, where my sample suppose is present in this particular sample holder, and the outcome of this analysis is always a graph. Okay, we get some graph here, and from this graph we have to make the interpretations. Now peak each peak has to be well separated from the adjacent peak. So that well separation is the resolution, that is the ability of that particular instrument to identify the two components separately and to show them separately on the graph. So if we get a peak or spectrum like this, that means the both the peaks are overlapping on each other, so this is not good resolution. Okay, but when I get a graph like this, that means they both are well resolved. So resolution is the ability to distinguish adjacent absorption bands. Next question is wave number is the number of waves per second, per centimeter, per inch, or per centimeter cube. So here we have to understand what is wave number. Wave number is the special frequency of a wave which is measured in cycles per unit distance. Okay, unlike frequency is what? Number of waves per unit time. Okay, so wave number is number of waves per unit distance, and wave number is usually measured in units of reciprocal meters or reciprocal centimeters. Okay, so this question, answer for this question is wave number is the number of waves per centimeter, and we usually use this term centimeter inverse in case of IR spectroscopy. The IR spectrum which we get, that IR spectrum is the percent transmittance versus wave numbers, okay, which is centimeter inverse. So at 3300 centimeter inverse I'm getting some peak, okay, or at 1640 centimeter inverse value if I'm getting any peak. So at specific wave number the peak is appearing, and that indicates the presence of the particular functional group. Next question is what is the concentration of paracetamol in 0.1 normal sodium hydroxide solution whose absorbance in a 1 centimeter cell at its lambda max 257 nanometers was found to be 0.825. So we have to find out the concentration. C is to be found out, and as per the IP monograph, the A1% 1 centimeter value is given as 715 at 257 nanometers. Okay, and these are the options given. If we closely look at the problem, 0.1 normal sodium hydroxide is the solvent which is being used for dissolving paracetamol. This 1 centimeter is nothing but the path length of the sample holder, okay, in which the sample solution is poured and through which the UV radiations will be passing. So this is 1 centimeter. Lambda max is 257 nanometers for paracetamol and 0.825 is given as the absorbance. The A 1% 1 centimeter, which is given 715, that is the absorptivity or specific absorbance, small a. Okay, so specific absorbance or absorptivity is small a and absorbance is capital A. So this is the formula, that is from Beer-Lambert's law. This is the Beer's equation. A is equal to ABC, where A is absorbance, absorptivity, path length and concentration is C. Now after substituting the values which are given in the problem, we get C as 0.001154 grams per 100 ml. Now this unit is very important. Why I have written it as grams per 100 ml? Because it is A 1% 1 centimeter, which is the specific absorbance provided to me. So whenever specific absorbance is provided, that means when A 1% 1 centimeter is provided to us, at that time the calculated concentration, it has unit of grams per 100 ml. Whenever molar absorptivity is given, the unit of concentration will differ. That we will see in the next question. So here the answer is C, 0.0011 grams per 100 ml is the concentration. Next question is the unit for specific absorbance A 1% 1 centimeter is. As I told you just now that A 1% 1 centimeter means the specific absorbance. Okay, and whenever specific absorbance is provided, the concentration, okay, the concentration has unit grams per 100 ml. So here if you can see grams per 100 ml centimeter, this centimeter is given here, it is given here also, and 1%, that is grams per 100 ml. So grams per 100 ml is not given, okay, but see here deciliter. What is deciliter? It is a metric unit of capacity and it is equal to 1/10 of a liter. Okay, 1/10 of a liter. So option D is the correct option. That is the unit for specific absorbance A 1% 1 centimeter. And whenever molar absorptivity is given to us, okay, in case of molar absorptivity, this C option would have been right. This is for molar absorptivity. Okay, so the concentration of sample solution is measured in moles per liter and length of the light path in centimeter. So the given absorbance which is unitless, the unit of molar absorptivity in that case would be L mole per liter per centimeter. This is for molar absorptivity, but here in the question molar absorptivity is not asked, specific absorbance is asked. Okay, hence the correct option is D.